Bismillahirrahmanirrahim. Greetings. This is the 8th lecture about the concept of series and sequence. Now, in this lecture, I'm going to go over the material of the previous one quickly, in orally and also in writing, and then continue for the next. Okay, then let's get started, shall we? So we started in the previous lecture from a simple example, 1 plus 2 plus 3 plus 4 plus 5, a series of 5 numbers, and then we subtract from that 1 plus 2 plus 3 plus 4, and we end up with number 5, which in this case was also the fifth terms of the series. Then we can do that for the rest of them. 1 plus 2 plus 3 plus 4 minus, parenthesis, 1 plus 2 plus 3 ends up with number 4, which is the fourth term of the series. Then we generalize this idea using sigma notation, and sigma notation is kind of compact form for the series, for the addition of series. And from that, we came up with the summation of I equals 1 to n ai, which is a1 plus a2 plus a3 and so on plus an, then minus summation of I equals to 1 to n minus 1, which is negative parentheses, again a1 plus a2 plus a3 up to an minus 1. And when we add these two series together in expanded form, we end up with the nth term of the series. And we can continue that one for others, like summation I equals to 1 to n minus 1 ai minus summation of I equals to 1 to n minus 1, which is n minus 2. And when we subtract the terms, we end up with the second term from the last. Then it came to our mind that why don't we try this idea with an example. So the example that we made, we said let's the sigma I equals 1 to n to be equal to n squared, which means if we have for example, if n is 7, there is a series, that if you add the terms of that series, if there are 7 of them, the summation of all of them will be 7 squared, which is 49. And by doing that, we generalized the idea, and we came up with something that we were familiar with, which was summation I equals 1 to ni, and we solved it for that, and lo and behold, we found a nice looking formula that we were not even looking for it. And that was the excitement of mathematics. Remember at the end, Ali got a little excited, and because mathematics give wing to the mathematicians, and he got a little bit excited and didn't want to go too far because I didn't want to hit my head on the ceiling. And that is really true. If it was outside, I could fly and end up on the moon. Okay then, let me put all this on the board one more time quickly, because repetition is the really best process of learning, has a very good effect on learning. Okay then, let me zoom it and stay out of way, and we go over that again quickly before we continue for the next. Okay, same thing that I said, I'm repeating. 1 plus 2 plus 3 plus 4 plus 5. This is the compact sigma notation of this. Less 1 plus 2 plus 3 plus 4, less this is the compact sigma notation of that. We end up with the fifth terms of this series. We can do same thing for 4, which is 1 plus 2 plus 3 plus 4, less 1 plus 2 plus 3, we end up with the second from the last term of the series. And by doing that, we can find all the terms of the series. So we have gone over that, from the previous lecture. Now, then what we did, we generalized this idea using what? Using algebra. All right. So what we did, we used in general I equals 1 to n ai minus this summation I equals 1 to n minus 1, which is one term less. And by doing that, we end up with the nth term. And if we continue, we will end up with each term from last to the first. You follow me? And then we came to the idea that, okay, suppose that summation of a series is equal, when you add all the terms, you get n squared. Meaning, for example, if the series has 10 terms, you end up with 100 when you add them all together. So then we are asking what are those terms of the series that when we add them, 10 of them, we get 100. So that was our curiosity for the last. And then, let me now go on that one. Again, I'm reviewing that. If you watch the previous one, is in more kind of detail. Quick review. Okay, now let me see. Same thing I'm repeating. Summation is n squared. We wish to find the terms of the series. So what I did, I subtract, I end up, when I used the general, which is a1 plus a2 and so forth, and end up with this, n squared minus n minus 1 squared. This one gives me n squared, is that right? And this one, what is it? This summation from I equals 1 to n minus 1 give me n minus 1 squared. And then when we use a binomial expansion for that, which is n squared minus 2n plus 1, and multiply by negative and add, we end up with this formula. Now, the advantage of this one is that we don't have to each time to go through this summation to find the terms, last term, then one next to that and next to that. This gives us all of them from end to the first. From end to the first. Then we say, okay, why don't we change it from first to the end, which is kind of more comprehensible. So I change it to I rather than n, and then I goes from 1 to n. So I end up with this one from the previous again. So we end up with, which is same as this one. So ai equals to this, so far. Then I sum both sides. If two things are equal, if we add summation, if we add all the terms to the left, and we add all the terms to the right of the equality will be preserved. Is that right? So that's exactly what we did, and we end up with this one. Do you follow me? And when we saw this one, we got a little bit immediately excited because we are already familiar with this from the previous lectures that we used absolutely different technique, and we get the formula for that. Isn't that fantastic, we said? So we solved it for that, and we got now a new way of getting this summation rather than going through the way that we did it in the previous, third or fourth lecture that we did. Okay, now let me go to the last of the review, then we can start the next one. Okay, now let me also cover this one. So I just distributed very simple arithmetic. I solved it for summation of I equals 1 to n of I. You see that I solved it, and I came up with this nice looking formula that I'm already familiar with. I have already found that one from different way. So again, I was very excited and I started to fly toward the ceiling. And lo and behold, we found that formula. Okay, now, so from this that we started, we end up with what? We end up with this formula. So now, curiosity tells us that what about if we start from I equals 1 to n, let's say I equals to n cubed rather than s squared, and see what formula it may end up, because we are kind of becoming very excited for finding a formula that we were not aiming for. So that curiosity gives us to continue. So that is going to be the subject of this lecture. So let me put this one on. So here we have a series, and that series, we don't know the terms of that series. We want to find out. Reverse engineering. So that series has n terms, and when we add all the terms of that series, we get n cubed. For example, if it is n is 10, we have 10 terms of that series. When we add all those terms, we get 10 times 10 times 10, which is 1,000. So the question is, what are these terms that give us this case? So we are trying to find those terms. So what we did, we generalized exactly what we did the previous one. We started from I equals 1 to NAI minus I equals 1 to n minus 1 term before. And then this series is n cubed. Is that right? So this series will be n minus 1 cube. Do you see that? Based on this assumption. And then this is a binomial expansion, which is what? N cubed minus 3n squared minus 3n plus, minus 3n plus 1 plus 1. Oh no, minus plus 3n minus 1. All right, then we distribute this negative to the terms of that, and simplify n cubed and n cubed, they cancel, and we end up with this. Very elementary, is a elementary grade school arithmetic. We end up with this. Now this gives us each term of that series, from last to the first. But we want to be from first to the last, so we changed it into I rather than n. So here it is. AI equals to this same formula. Now this gives us the terms of this series from first to the nth term. All right? Then we sum them all. All the terms to the left, we add all of them together, and we use the compact sigma notation for that, and we end up with this equal to the same thing. And then we distribute the summation that we are familiar, we have covered in the previous lectures, and then we end up with what? We end up with this one. And here it is, lo and behold, again, we came up with beautiful another formula that we were kind of this time expecting. Now, this one, let me use this one. This one, we know that is n times n plus 1. This one is I equals 1 to n1 is equal to n, because when I is 1 is 1. When I is 1 is 1. When I is 2 again is 1. When I is 3 again is 1. So 1 plus 1 plus 1, how many of them? N of them. So this end up to be summation of, end up to be n. So we know this, we solve for this one, and we come up with a nice looking formula for that. So we know also what this summation is, which is n cubed. So we go now to the next. Very similar to the previous lecture, and Okay, now let's go to this one. So we are solving for summation of I equals 1 to n of this I square. We are solving for that. Then we end up with this one. Then we divide both sides by 3 so that we end up with this summation alone. And here it is. We divide both sides by 3. And then the rest of them is grade school algebra, grade school arithmetic. We add all of them, they must have same denominator. So the least multiple of the 3, 2, and 3 is 6. So we multiply numerator and denominator of this one by 2, multiply the denominator of this one by 3, multiply the numerator and denominator of this one by 2, and the denominator becomes 6, and we end up with this algebraic expression. And when we simplify and we factor, we end up with this formula. Lo and behold, fantastic, look at that. And this formula, we are also familiar because we got this formula from using function in the previous, 3 lectures. We used the function and algebra, and that way we find this formula. And I have it, let me hang it up for you from that lecture that we used. We got the 3 equation with 3 unknown, and we found that formula. And that is exactly the formula we got it this time. You follow me? Okay, then let me zoom this one up. Okay, my dear friends, I hope this series of lectures are beneficial and helpful to you. I'm uploading for the benefit of general public, once for my own fellow Americans student, and second for the rest of the world, whoever may be watching, and I hope they are kind of beneficial and they can benefit from that. Okay, then if you have any comment, please do not shy away to mention it in the comment section, and anything you want to add or something, I'm very open to that, and I can make changes. And I'm responding to the ads. Inshallah, soon I may find a good position. Then I will try to use the facilities of that institution for better videos. Okay, then, as always, I wish you good health and prosperity, and please stay and remain safe. So long.